The most expensive stuff in the universe, antimatter, has a fascinating history. It was first theorized in 1930 when scientists discovered the electron and hypothesized that an opposite particle should exist, which they called the positron. Eventually, other antiparticles such as antiprotons and antineutrons were also proven to exist. When a particle and its antiparticle collide, they annihilate each other and release an enormous amount of energy, much more than a nuclear reaction. However, creating antimatter is a complex and time-consuming process. It takes approximately 100 billion years to create just 1 gram of antimatter, and currently, the only way to create it is through the use of the Large Hadron Collider. Due to the high cost and difficulty of production, antimatter is estimated to be valued at around 62 trillion bahts. Moving on to space observation, throughout history, only 2 objects from another star system, or possibly another galaxy, had entered our solar system. The first was the Oumuamua asteroid, discovered in 2017, and the second was the Borzov comet found in August 2019. These objects provide valuable insights into substances that may have originated from other galaxies. An unusual teardrop-shaped star has also been observed, which has almost twice the mass of the Sun. This star appears like a big drop of lava due to the presence of a nearby dwarf star that affects its surface by attracting its energy. Similarly, black holes can distort the surface of nearby stars through their gravitational pull. In a remarkable event, astronomers observed a star located about 215 million light-years away that got spaghettified by the gravity of a nearby black hole. The star stretched and emitted a thin ray of matter as it was being consumed. The black hole also ejected billions of tons of star material into space. Another intriguing event occurred approximately 250 million light-years away, where a red giant star came too close to a massive black hole around 400,000 times heavier than the Sun. Surprisingly, the star managed to escape, although most of its outer layers were consumed by the black hole, leaving behind only the molten core, a white dwarf. The white dwarf continues to orbit the black hole while losing mass due to the black hole's influence. Eventually, the star will cool down and transform into a planet resembling Jupiter, but this process may take around 1 trillion years. It has been scientifically proven that a planet can orbit a black hole similar to how it orbits a star. However, for a planet to survive near a black hole and avoid being pulled into the event horizon, it would need to orbit at an extremely high speed, nearly the speed of light. Additionally, the black hole itself must be rotating at the same speed. Imagining life on such a planet raises interesting questions about its unique conditions and energy source. Overall, these discoveries and observations highlight the remarkable aspects of our universe and continue to inspire curiosity and further research. The corrected paragraph with punctuation is as follows. Fast earthquakes on the moon, or, shall I say, moonquakes, aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Marsquakes too. For a long time, the red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars' surface, but it means some geological processes are still going on underneath the red and dusty landscape. At a distance of 640 light-years from the Sun, scientists discovered the planet WASP 76 bits, where it rains iron. The planet is very close to its Sun and always turns to it with the same side, a term known as tidal locking. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite. It's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. Turns out there are plenty of planets in the universe and even in the Milky Way galaxy that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, There's an actual ocean of water, but it's too soon to be hyped about possible life on other planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that it could fill all of our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that not only left behind mighty craters but also the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water that it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to the fossilized remains of living beings, but also came from outer space as well. And yet, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone, and not just any planet, mind you. It has a rocky core and surface and is of a comparable size to the Earth. Being inside the habitable zone of a star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only inhabitable but inhabited already. And now multiply this by the number of galaxies in the universe. Also, considering that many of them are much bigger than the Milky Way, this gives us billions upon billions of sun-like stars and Earth-like planets, and some of them are surely more like ours than others. Until recently, we thought our galaxy looked like a circular spiral, but recent research has shown it looks more like a Pringles chip. Scientists measured the distances between the Sun and other stars and created a three-dimensional map of the Milky Way based on this data. It turned out that our galaxy is slightly curved at the edges and takes an S shape. At this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Apus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros. Megaton explosions happening once a millisecond